Hello, everyone. Welcome back, and thank you all again for joining us at the 2021 MIT Water Summit. For those of you just joining us, we've got a great lineup of speakers this afternoon. The program is available on our website, but it can also be found if you scan the QR code on the backs of the seats. So I hope you guys stay with us for the rest of the afternoon. Right now, I'm gonna just jump in and introduce our next speaker, Dr. Paul Kirshen of UMass Boston. Paul Kirshen has more than 40 years of experience serving as Principal Investigator of complex interdisciplinary participatory research related to water resources, coastal zone and infrastructure management, and climate variability and change. He was the lead author of the IPCC Fifth Assessment Report, Water Resources in North America, and the 2014 U.S. National Climate Assessment Coastal Zone. Working at scales ranging from the local to international, he's been conducting research and consulting on the integrated vulnerability of Metro Boston and Massachusetts to present and future climates and adaptation management strategies since 1990. Recent adaptation experience has also been in other parts of the northeastern US and the Caribbean. His research on the impacts of climate change has been cited by the US Supreme Court and has won several professional and civic awards. He's also an alumni of our institution. He got his PhD here in civil engineering. So with that, I can turn things over.
Thank you very much. Can you hear me okay? Oh, you click it, right. Thank you, James. Yeah, it's nice to be back on MIT's campus. Around 50 years ago, I was a student here in civil engineering, studying water resource management, and living over at Eastgate, which I see they're rebuilding right now. So what I'm going to talk about is managing coastal flooding in Boston. And in particular, I'm going to talk about using what we call nature-based solutions or nature-based systems to manage the present increased coastal flooding. So I'm just going to jump into this, and then I'm going to talk maybe 25 minutes or so, and then after that we can have a discussion. And if any pressing questions come up between now and then, please raise your hand or speak out or something. So I thought I'd just start off with what a nature-based solution is. This is from the European Commission. Nature-based solutions, or NBS, are inspired by nature, use nature, and/or are supported by nature. Specifically, nature-based solutions have been defined as living solutions underpinned by natural processes and structures that are designed to address various environmental challenges while simultaneously providing multiple benefits to economy, society, and ecological systems. So a simple example of a nature-based system is if an area is getting flooded along the coastline, instead of building a concrete wall, why don't you elevate the coastline with park? And on the coastal side of the park, create intertidal habitat, so you have ecosystem benefits. And then on top of the park, create a playing ground, plant trees, create more open space. And so you have social benefits. So here, by elevating the coastline with this parkland, you provide flood protection through the elevation, and you also provide ecological and social co-benefits. And many cities, as you know, most of the world's population now lives in cities. Most of those cities are along the coast. Those cities along the coast are very impacted by climate change, not only from the stresses from the ocean, but also from inland stresses. So I'm going to talk a little bit, before I start the talk, I'm going to be talking about a little bit about the stresses Boston is facing from various kinds of climate change, and then dive into hopefully the advantages and some of the challenges of the city using nature-based solutions to protect itself from flooding. So City of Boston is facing these stresses: sea level rise, coastal storms, extreme precipitation, and extreme temperature. And this just shows the impacts of extreme temperature in this area. Right now, City of Boston has about 10 days a year over 90 degrees Fahrenheit. By the end of the century, it could be as little as 25 or as much as 90. If it's 90, it would mean every day of the summer is over 90 degrees Fahrenheit. And then in terms of extreme precipitation, right now, this is the amount of rainfall we get in a 24-hour storm that has a probability of occurring every year of 10%. So right now, it's a little over 5 inches. End of the century could be 6 or a little bit more. So again, it's increasing. When I was here at MIT about 50 years ago, the value, instead of being 5.2 inches, was around 4 inches. So we've seen quite a bit of change in extreme rainfall. And then sea level rise. So by mid-century, we could have anywhere from 7 to 1.5 foot of sea level rise compared to 2,000 levels. By the end of the century, it could be 2.5 to 7 feet, or as much as 10 feet. And of course, you realize why these ranges are uncertain. One is we don't know what the emissions of greenhouse gases are going to be in the future, and we certainly see that coming out of COP26. And then also, there's certainly some dynamics of the ocean and the climate system we don't fully understand yet. So the 2.4 is a low value of a scenario, 7.5 is the high end. And of course, dealing with a range like this makes designing for future sea level rise and associated coastal flooding very difficult. And also I want to point out that all these stresses, right? They all compound each other, and you can't just say, "Oh, I'm just going to manage for sea level rise," without worrying about the increase in extreme precipitation or the increases in temperature. They're all impacting the city together. And but I'm going to focus on the flooding. So over here on my right, we show the flooding from the 100-year storm, the 1% storm that could occur in the period 2030s to 2050s. And again, we don't know when this might occur because of the uncertainty in the sea level rise projections. But you can see, let's see here, where's the pointer? Okay, anyway, doesn't want to show up, but actually you can see MIT on this. But you see, a moderate amount of flooding in Boston and the area. And then in the center image is the 10% flood, which would be occurring around maybe 2050 to 2100. Notice that the images, the amount of flooding is very similar. So an area that gets flooded now once in the average every 100 years, by mid-century or later, might get flooded once in the average every 10 years. And then on the far side, you see the flooding that could occur once a month in this area. And again, you see the plots of the area that's flooded are very similar. So an area it gets flooded perhaps in the average every once in every 100 years right now, end of the century, a little bit beyond, might get flooded in the average every month because of high tides. The other thing to think about is, who's getting flooded. And this just shows plots of population groups that have been marginalized or oppressed because they're older, they're children, the people of color, low income, and so on. And you can see, if you compare this image with this image, a lot of these areas where there are these unfortunately marginalized people are the same. So this brings up the whole concept of environmental justice and climate justice, which, as I'm sure you're aware, is also a big theme at COP26. And, these are images from the storms we had in January and February of 2018 in Metro Boston. Essentially, we had 200-year floods in a row. And, in parts of Boston, the flooding was quite severe. In my lifetime, I've never seen this amount of flooding in this area. And this flooding, it can cause quite a bit of damage. This over here on my right shows the increase in the mean annual damages from flooding from, a couple of decades from now up to past 2100. This is the mean annual damage that would be occurring from coastal flooding. And then on the other side of the screen, you can see what's being measured here. And most of these are damages to buildings and contents. It doesn't talk about a lot of the indirect damages that are occurring, or certainly magnify these costs. So this flooding, besides causing damages to human health and death, also causes a great deal of economic damage and disruption. Also, this it also does not include damage to infrastructure, like flooding the MBTA stations, flooding the big dig tunnels, and so on. And one of the early strategies to think about how coastal flooding could be managed in Boston was to build a large hurricane barrier. And this image on my right shows the extent, 100-year flood in Boston Harbor area right now. On the other side shows the extent of the flood perhaps by mid to late century. And there was an idea to build a, wow, look at that. To build a barrier from Winthrop here through the islands to Hull. Another idea was to build a barrier here. So you can see if you had a large barrier here with gates in it to be open for shipping, you could block a lot of the flooding. And so we did a study of this, and we found out it really didn't make sense to even consider building these large harbor-wide barrier systems till at least the end of the century. And the reasons were the economics, it was incredibly expensive, the fact that if you built this, it wouldn't be built till 2030, and because of it wouldn't be built till 2050 because of the permitting and construction challenges. And between now and 2050, you'll still have to deal with coastal flooding. So you have to do something between now and 2050. And there are also some other sorts of technical reasons as well, plus environmental reasons. So it doesn't make sense to consider this until the end of the century. So what's the alternative? Well, the alternative was greening the coastline with these nature-based systems. And our report came out in May of 2018. Then in October of 2018, the then mayor of Boston, Marty Walsh, said, instead of walling off our harbor, we need to work with it. Shoreline products are more feasible and more effective ways to increase our city's resilience. So essentially, he proposed greening the entire harbor with nature-based systems, essentially elevating the coastline with these nature-based projects to protect us against present and increased flooding, both from coastal surges as well as high tides. But the devil's always in the details. And so instead of using these monolithic concrete structures, we're talking about things like this. This is a sketch, a conceptual design of a nature-based system for Charlestown. And you can see over here, it's terraced, right? Like a beach. A beach is a natural flood protection system. It's terraced. Oftentimes behind a beach, you have dunes as well and marshes. So it all works as a natural system to protect against flooding. So here you have man-built terraces. Over here you have ecosystems. And of course, the whole area is a parkland providing social co-benefits to the community. And then here's another one. This is proposed for Fort Point Channel. As many of you may know, Fort Point Channel is sort of a granite lined channel. Well, the idea is to green it. And again, you see the sloping, you see the ecosystems, and you see it being used for recreation. This is a nature-based system. And then this is another one for East Boston. There's actually a berm proposed for the Greenway in East Boston. Again, the elevation, the open space, ecosystem benefits. And Boston right now only has one nature-based system in place. This is Clipper Ship Wharf in East Boston. And this is it at high tide, unfortunately. But offshore here, you can see these granite blocks. And those are designed to break up any wave energy that might come in. And then on shore, over here, it looks like this. And so you see, again, the sloping, you see grass, and the offshore granite also provides habitat. So again, here's a system providing flood protection, open space, ecosystem benefits. Now, these replicate natural systems. So over here is a tropical system. And as you see, it's a tiered system. Offshore there's coral reefs, other kinds of reefs, slope beach, mangroves. It's a layered system. And these are things we're trying to replicate. Over here is Boston has these offshore islands. So when we get a major storm outside the islands, the waves could be 20 feet high, but by the time that waves go through the harbor and go through the islands, they're only a couple of feet high. So again, it's a system that's breaking up the wave energy. And then in my upper left, that's, I think that's Plum Island. So again, sort of a barrier beach system. So the tiered system, right? Barrier beach, marsh, elevation. So these are the kind of systems we're trying to replicate with these nature-based systems. And this just shows how effective they are. So in the upper image, you see an area before Sandy with the marsh system, with a dune and vegetation system in front. And then the other image, you see what looked like after Sandy. So it was protected. In the lower image, you see an image right here with no protection. And then after the storm, after Sandy, it's pretty much non-existent. So these nature-based systems can actually work. As we pointed out when we did the study for the harbor barrier, and we suggested alternative being nature-based systems, there are many advantages of these. First of all, as I said, if you're going to build this offshore barrier, it wouldn't be in place till 2050. You can build these nature-based systems well within a decade. Also, there's less technical challenges building these nature-based systems on land. And also, they're a lot cheaper. The benefit-cost ratio for these offshore harbor-wide barriers are all less than 1. But these systems, these nature-based systems for Charlestown and Boston, their benefit-cost ratios are well greater than 1. So they make a lot of economic sense. And then, of course, the nature-based systems create ecological and social co-benefits. And then, perhaps most importantly, if you're going to build a harbor-wide barrier, here we are in 2020. We'd say, okay, this is going to get in place by 2050, and we might want it to last at least 100 years. What amount of civil rise do we plan for? How much increase in intensity of coastal storms do we plan for? If you overestimate, you've overinvested. If you underestimate, you're going to cause a lot of damage. The advantage of these nature-based systems is you can build them as you need them. The entire coastline of Boston, the elevation varies. So right now you can build the low elevation areas first. As sea level goes up, you can build those higher and then build additional areas. So you have this incredible flexibility in adaptation to deal with the uncertainty of the future sea level rise. And then this offshore barrier will not be able to manage tidal flooding. You can't be closing these gates, once a day or twice a day. Whereas nature-based systems, we've elevated the coastline, you're going to protect yourself against tidal flooding as well as storm surge flooding. And then also, interesting, the nature-based systems, have certainly a lot less environmental impacts than an offshore barrier. In fact, by creating intertidal habitat, you're going to create all sorts of positive ecological benefits. But there are research questions about nature-based systems. So one is, a real natural system can perhaps keep up with sea level rise and might adjust over time to future sea levels. Well, is it possible to design and engineer a nature-based system to do that? Also, if we build a nature-based system, what about the sustainability of the vegetation and the sediment supply for that system? And then, can a nature-based system self-recover from a storm? So all sorts of questions about nature-based systems. To give a little example. So this is East Boston, and there's major flood pathways through here, and then right through here. I'm going to be talking about this area here, which is Border Street. And so this just shows this area of Liberty Plaza area. And this is like, I don't know, maybe a possible 100-year flood in 2030 or 2050. So you see it flooding large parts of East Boston. Actually, it floods into the Sumner and Callahan tunnels, which flow into Boston. And so this area of Liberty Plaza is a very important flood pathway, which has to be managed. So this just shows what the area looks like right now. And so working with community members, and we said, what would you like this area to look like? And so they said, well, we want this parkland here, we want elevation. But more importantly, they said, we want affordable housing. Because one of the big problems with nature-based systems, if you make an area greener and more resilient, you're going to draw people in, and you're going to raise rental prices, raise housing prices, and be driving out the people you're trying to protect. So the residents we were working with in East Boston said, no, we want at least 30–40% of the housing built in this area to be affordable housing. And then another interesting thing here, we looked at, as I said earlier, when you look at the benefits to these systems, usually measure that by damages avoided. What's the value of the buildings you're going to protect and their contents, maybe the value of infrastructure, and so on. Well, as I said earlier, there are a lot of social co-benefits with nature-based systems. So let's try to incorporate them into the calculus, perhaps put them into the benefit cost calculation. So can we possibly monetize some of these social co-benefits, which are particularly important in environmental justice communities? So we looked at 1 to 5 possible social co-benefits from building nature-based systems in this area of East Boston. So for example, air quality, right? So if we create more open space, particularly trees, we're going to improve air quality. If we're going to protect the T, yes, we can protect damage to the T, but also we're going to allow people to get to work. And so we monetize these, and this is the results. And again, monetizing social co-benefits is always a little risky. It's like trying to monetize ecosystem benefits, but it's worth doing just as an exercise. And so over here, we show in the period 2020 to 2030, the present value of the unweighted social co-benefits is like $67.2 million. So this is like taking the time stream of benefits and discounting them back to the present. It's like $67.2 million. And then you compare that to the conventional economic benefits, $115 million. So this value here, 67, is more than 50% of the conventional benefits. So it's very important. And then if you go further out to the end of the century, the total social co-benefits, 130 million or so compared to 640. Still a significant value compared to the conventional benefits. So again, while it's always risky to try to monetize these social co-benefits, it does show the significance of them, that they really add value to a project, which should be considered in project design. And then, but as I said earlier, there are challenges with nature-based systems or research gaps. And so, for example, came out in 2017. There are no comprehensive nature-based features guidelines available to support practitioners and so on. So actually, some guidelines just came out in 2021 from the U.S. Army Corps of Engineers. But these guidelines do not talk too much about nature-based systems in urban areas. A lot of these are on like river systems or in wetlands and parks. They don't talk about how would you actually design and build a nature-based system in a place like downtown Boston. So we're still lacking information on this. And then there's also information on, we need to know more about the advantages of these coastal ecosystems we're trying to restore and use as co-benefits. And then also, we need to know more about, these social co-benefits. So a lot of gaps in our knowledge about these nature-based systems. And just to sort of bring this down locally, this is a map of New England, right? And New York, New Jersey area. I don't think any one of these cities has a major nature-based solution in place yet. The only one I know of is really in Boston, and it's in a downtown urban area. So the fact that there aren't many in place, or if there are, there are very few, there's no real database of how they behave. And we really need that data to understand how they behave. So there's a real lack of local information on how these perform, particularly in urban areas. And then some colleagues at UMass did a survey about municipal concerns in nature-based systems. And I'm not gonna go through a whole list, but how to fund them, right? Lack of public awareness, insufficient metrics, a lack of technical expertise. They need case studies, public engagement information, municipal training, and metrics to monitor progress on how well nature-based systems work. So there's a lot of questions about these systems. And also, one of the big problems is permitting. In the United States, but particularly in Massachusetts, it's very difficult to build something where it requires filling in the coastal zone. And of course, when you build a nature-based system, it's going to require some filling in the coastal zone. And this just shows the complexity of the permitting process to possibly get a nature-based system permitted right now in Massachusetts. It's about a 2-year process. And there's no guarantee you'll get it. So we obviously need reform in the permitting process. And so this brings me to what I'm doing right now. So in January of 2020, several of us, a partnership, launched the Stone Living Lab. And it's really to look at these questions of the biophysical performance and the socioeconomic performance of nature-based systems in the northeastern United States. And it's a partnership of UMass Boston, Boston Harbor Now, which is an NGO trying to create public access to the harbor, the National Park Service, and the City of Boston, Massachusetts DCR. And the lab is actually centered in the Boston Harbor Islands. And our idea is to, I'll skip this. The idea is to, on one of these islands, in particular Rainsford Island right here, which is an 11-acre island, to actually build full-scale nature-based systems where we can test out their performance in a heavily monitored environment. So right now we're trying to get the permits to build these experimental nature-based systems so we can test out their performance. And we're also heavily monitoring not only the experiments when we get them in place, but also right now we're in the midst of monitoring the perimeter of the island. So we're putting in current meters, water quality meters, we have a met station, we have current meters, we have all sorts of other kinds of instrumentation. So we'll be able to monitor how well these systems perform. So this equipment is going in place right now. And this just shows some of our data buoys. And so our plan, again, we're in year 2 right now. We're carrying out a bunch of activities. So we're looking at sediment transport in the island. We're doing LiDAR scanning right now on land of the northeast face where there's a bluff which is impacted by coastal storms. We're also looking at the idea of what we call livable seawalls, living seawalls. In some areas, you have to build a concrete seawall. But say you create on that surface of the seawall a surface that can create habitat through crevices or certain kinds of materials. So actually testing out various kinds of material and crevices on seawalls, see how they behave. And then also, because it's taking a while to get our permits, we've started monitoring some existing nature-based projects in the area. So we're monitoring a park in Winthrop where they have a nature-based system. We're monitoring a couple of projects in Duxbury. We're monitoring one project down in Chilmark on Martha's Vineyard. Again, these are not urban areas, but they do provide us the opportunity to monitor the performance of some nature-based systems. And then once we get our permits, we're going to be doing things like looking at the performance of cobble berms. Cobble is like boulders, like maybe this big. And so they're really great because they move. If you get a storm, you get waves, right? They move, and then they go back. So they absorb the wave energy, and they go back. And if they're put in with the system where there's some elevation, you can also protect against flooding. And then we're also doing some policy research. We're looking at developing robust policies for developing these systems. What are some financing strategies? What sort of regulatory reform is needed? How can you build public-private partnerships to get these financed? Because in Boston, the mantra is, we don't want a Sandy here. We want to get our coastlines protected before we have a major storm. And the only way we're going to do that is to have public-private partnerships to pay for it. We can't wait for a Sandy to occur and then get $60 billion like New York City. We got to get this stuff in place before then. And then also, even when we get these experiments in place, obviously these experiments are not going to be subject to every single climate condition or weather condition. So we hope to use that data to build computer models of the performance of nature-based systems. And we're also looking at regulatory reform. Then also, not shown here, we just launched 3 projects looking at detail on some of the social co-benefits of nature-based systems. And so this just shows the experiment we're working on at Cobble. We're doing it at Winthrop, Massachusetts. So this is Winthrop over here. So downtown Boston's over here. And there's a park here. This was it before, and this is it after. So what they've done is they've built cobble up here. They've elevated this a little bit, as shown up there. And now we're monitoring the performance of this. So we're doing biological surveys. We're doing shoreline profiles. We're doing drone monitoring. We're monitoring offshore currents. So we can really understand how the system behaves under weather conditions for the next couple of years. And so we'll be doing this kind of work on Rainsford once we get going. And also we're working in the Stone Living Lab on community engagement. We have educational programs, K through 12. We're doing community science and all sorts of activities. And that's shown here. So with the Stone Living Lab, we're trying to address some of these challenges related to nature-based systems. So I'm glad to take any questions or comments, and thank you very much.
Thank you, Paul. We have a couple questions that have come in on the webcast, but I'll get up here.
By the way, he's doing that. How many of you are students here? Okay. And how many of you are in engineering? Okay. And then how many of you in liberal arts? Or okay. How many of you in planning? Yeah, you're in DUSP and, okay.
Got a mixed group.
Okay.
Hi, my name is Lydia from DUSP. Thank you so much for this talk, very interesting. You talked about the problematic of permitting. It takes 2 years to get these permits on. Is it the case that this period is shorter for traditional gray infrastructures of the same characteristics? Or is it just a matter that you require so much time? And whether you think that there is any benefit to this period where you can actually then use some of these processes to find out what can be some of the social co-benefits. For instance, if there is public participation within this permitting process, do you see any bright side in having this long period?
That's good. So I believe the process would be the same if you're building gray infrastructure. And you're right, in the intervening period, this 1 or 2 year period, you could be working on, stakeholder engagement. You could be extending your monitoring of the biophysical aspects of the site. But hopefully, though, before you design a project, you've already worked with the public to design the system. So you might be, again, expanding your social economic monitoring during that period. But hopefully before you've designed it, you've already worked with them. There's also a lack of information on who uses these sites after they're built. For example, that site at Clippership Wharf in East Boston, Is it only used by the wealthy people that live in Clippershift apartments, or is it used by a lot of the low-income residents of East Boston? And there's data lacking on that, but it's sorely needed. Thank you.
Any more questions from the audience?
One would think that insurance companies would be all on board with this, because anytime you can protect property, it's going to save them money. Are they on the forefront of helping out with this and getting things moving along?
I really can't answer that question. I know the insurance companies are very, very concerned about, climate change impacts and coastal flooding. I don't talk too much with insurance company executives, but when I've been around them, they're generally, supportive about concepts like this. Because again, it's a no-brainer, as you point out. The benefit-cost ratio is so large. Every dollar you invest, you avoid like $4 to $10 worth of damage. And that's, it's a real underestimation of the actual benefits of these things. So I'm assuming the insurance companies are onto these things.
This is sort of kind of off that same point, but do you feel like policymakers are sort of the people that decide whether these projects get permitted and get implemented? Do you think there's still a lot of skepticism?
Yes. I think the permitting community, because there's so little data on their performance in the Northeast, is very skeptical about how well they're going to perform. And they're very concerned also about the ecological benefits. Because if you build one of these, you are going to have to do some filling, bury some existing benthic habitat. But in Boston Harbor, the benthic habitat is not particularly good. In the water column, it's pretty good, but on the bottom, it's pretty contaminated still. So our argument is, look, yes, we're restoring a little bit of bottom habitat, but we're creating a lot more healthy intertidal habitat. And so like everything in life, there's trade-offs here you have to look at. But they seem pretty rigid right now.
In the meantime, I can ask a question from the webcast. Do you think all new construction and/or product design should be mandated to perform a biophysical and socioeconomic benefit analysis before starting?
Yes, 100%.
Okay, James.
And I learned that when I was a student here. I was doing water resource projects. The multiple criteria, economic, social, environmental analysis. It's so true in this.
Thank you.
Hi, I was having a little bit of a deja vu moment. So I was part of the conversations when they were talking about private partnerships for the innovation district, getting all the stakeholders involved, bringing the people to the table. Wonder if you wanted to, reach out to some of them, like, how did you guys do it? And, what can we learn from? What should we do? What should we not do? Because it's very, very similar conversations.
I didn't quite understand all your question, but I think you're talking about the the seaport area.
Yes, so these were the same conversations that were happening back then to create the private partnerships and public partnerships that needed to occur for that change to happen.
That change to happen for coastal resilience, or that change for
for the startup ecosystem. So Innovation District was all about, how do you create these new environments for startups? And there were all these questions. Is it really going to happen? What's the return on investment? Who's helping, who's not helping? Who are the stakeholders involved? The insurance companies, the banks, right? All these other players. Very similar conversation.
Yeah. But as I understand it, though, they didn't look at coastal resilience as part of those conversations.
No, of course not.
And unfortunately, what happened in the seaport, we lost a huge opportunity to do something right here. And what happened there is all those buildings were permitted, decade or more ago, and they're all grandfathered. So once they decided to build, they just went ahead and built. And while they, you may have some successful, economic investments. The area is, a bullseye for, climate change impacts from present increased coastal flooding. And also it's a little bit of a, wasteland. And one of the big challenges right now is how to green that area so it becomes a little more less of a social wasteland, and also becomes a little more ecologically rich, in addition to becoming more resilient to climate change. But that's going to cost, I think the number's like $100 million to do that, which could have been, didn't have to be spent. And so it's really frustrating because it could have been a great opportunity. And the last opportunity we have in Boston is down near UMass Boston, Dorchester Bay City, which is right near between Moakley Park and Columbia Point, where UMass Boston is, right near the JFK UMass station. So that used to be a parking lot. Now that's going to be developed into, some sort of, high-tech area. And so the group that's doing that seem a lot more tied into the challenges of dealing with climate change. It was what happened down at the seaport. And also, the Boston Planning Development Administration, 20, 30 years ago when they were thinking about the seaport, BPDA is now thinking about climate change. They've now created special, resilience zones. So there've been a lot of changes since then. So I think Dorchester Bay City hopefully will go a lot smoother and result in a better product than the seaport. But I go to the seaport and I cry. It's just so upsetting. Because we lost a huge opportunity. Now it's going to cost us, tens of millions to rectify it, which could have gone into, new schools and all sorts of other things we really need around here. So hopefully we've learned from that experience.
We have time for one more question, James. Is there a question from the audience? Upper corner, James, right over there.
On the other side.
Or, other
Yeah,
corner,
for sure.
sorry.
All right, just had another question. You mentioned that you are testing in an island nearby some of these systems, and I was wondering whether you could, on layman terms, explain a little bit more about what does it go into this performance testing, and how do you define performance in this case?
Those are great questions. About the second question, how do you define it? There are no real good metrics yet that exist for defining a successful nature-based system project. And that's one of the things we're thinking about doing for a research project. But things you look at, like, does an ecosystem develop and does it survive? Does it manage the flooding? What happens after a major storm? Is there anything, is it damaged? After a major storm, if there was some minor damage, does it rebuild itself? And then over a longer term, you might ask the question, as the climate changes, let's say over a 5 or 10 year period, what happens to the vegetation there? What happens to the ecosystem? Can that change? And so those are the sort of things we're looking at. Let's see, I think the first question is, what's the nature of the experiment, right? So one of the things we're doing, is this is a colleague of mine at Woods Hole Group, which is a coastal engineering company, thought about this. Most of the shoreline of Boston right now is lined with gray granite blocks, right? Think of the area near the aquarium, downtown Boston. It's lined with gray, all the shoreline is built up with gray granite blocks. So it's a very hard surface. So you get a major storm, not only do you get flooding, you also get a lot of wave energy, which weakens them. So let's think about taking some of those granite blocks, take them off the coastline, and moving them offshore, and creating like a reef made out of these granite blocks. So the reefs, like a natural coral reef off an island in the Caribbean, breaks up wave energy. These offshore reefs created out of granite taken from the shore would break up the waves. And then on the shoreline, instead of having a hard shoreline, you could build something soft, like a park or a wetland or some other soft feature. But you couldn't do that because of the wave energy right now. But by moving these things offshore, okay, so this is a great idea. We want to test that out. And it turns out in the northeast face of Rainsford, there's a crumbling granite seawall. And we are going to take that and move some of the blocks offshore, build something soft onshore, and see what happens to the habitat on the offshore blocks, and then see what happens to the shoreline when we create something soft there. Does this idea work? So that's the sort of things we're going to be doing. Thank you.
Great questions.
Okay.
Let's give another round of applause for Paul Kirshen. Thank you.